This problem is showing us a discrete function. In other words, a bunch of points. This is not a line function, it's just a bunch of dots. And it's saying the following. If I have a whole bunch of x values, okay, that's this top row, those are my x values, then I have a corresponding whole bunch of y values. These are like coordinate points. And then we go one step further, and I say, if x equals this, what's y? If y equals that, what's x? So let's try this first question right here. And I'm going to rephrase this to say, if x equals 9, what is y? That's essentially what this is asking. It's saying I'm going to give you an x value, and you evaluate it using this table to find the y value. So all we do is we go into our table right here, find the x value that we're talking about, and look up the corresponding y value, the coordinate point that matches it. So that's going to be a y value of 5. I can do the same thing for the next one. It's a little bit backwards, but look at what this is really saying. It's saying if this time y equals 4, what is x? Okay, well, we go to our table. We say, where's the y values? That's the bottom row. There's y equals 4, and there's the corresponding x value. Okay, so that's 7. Now, where things get a little interesting is when we start talking about the inverse functions. So let's pull this C question down here. Look at what this is saying. Let me just write it down, and then I'm going to translate this into something we're a little more comfortable with. The inverse function evaluated at 9 equals something. So rather than talk about the inverse function, because that is weird, one option we have is to evaluate the function on both sides, using each side as an argument. Now just bear with me and watch what happens here. If I take the function of the inverse function evaluated at 9, f and inverse f cross out because they're inverses. They have this composition effect. So what I get is just the 9 left over. 9 equals f evaluated at a certain point. Okay, well, now all of a sudden that looks more familiar. Where I have the y value, 9, okay, that's this guy right here, and I'm looking for the x value, which in this case would be 4. Okay, let's try that again with the last part of this. Come down, bring D down here. So this is going to be f inverse evaluated at, and I'm going to replace that x with a question mark, because I think if I have too many x's flying around in this problem, it really does get confusing. So I'm going to say f inverse evaluated at something, I don't know what that is, equals 1. Well, I'm going to use each side of this as the argument for some function. So I rewrite it like this. And now where I see f of f inverse, I can cross those out. Okay, this is the composition effect of inverses. And what I get is question mark equals f of 1. Or in other words, if my x value is 1, let's find that in our table right here. X value is 1. What is the corresponding function evaluated at 1? In other words, the y value. So that'll be 6. Now, yeah, I know it says if x equals 6, but remember what x is representing. It's just representing the argument of the inverse function. So in this way, you kind of step through this table, keeping in mind what's the input and what's the output.